Welcome back, ladies and gentlemen. Today we're doing 9.3, convergent and divergent sequences, okay? So we'll explain what each of those words mean. Quick little do now. We're going to write the first six terms of an equals negative 3n plus 6. Thankfully, this is explicit, so it's going to be really easy to work with. So a1 is going to be negative 3 times 1 plus 12. Okay, well, that's easy. That's just going to give us 9. Okay, a2, that's going to be negative 3 times 2 plus 12. Well, that gives us what? Negative 6 plus 12, so that gives us a 6. All right, a3, that gives us negative 3 times 3 plus 12. That's negative 9 plus 12, so that gives us, let's say, a 3 there. Okay, a4 gives us negative 3 times 4 plus 12. Oh, that one's just negative 12 plus 12. Gives us a big fat 0 there. Okay, then we have a5, negative 3 times 5 plus 12, well, that's negative 15 plus 12, so now we're in the negatives. And then a6 equals negative 3 times 6 plus 12. Well, that gives us negative 18 plus 12, which is negative 6. Well, we see a pattern here. This is clearly decreasing. And so if we plot these points really quick, so we had, let's see, 1, 9, and then it was 2. What did we get for 2? 2, we got 6, and 4, we got, sorry, at 3, we got 3, and at 4, we got 0, and then at, let's see, at 5, we got a negative 3, and then at 6, we got negative 6. Okay, so there's a clear downward motion there. And so back all the way in Unit 1, we examined the end behavior graphs of functions. We learned that as domains of some functions approach infinity, okay, so as we get closer and closer and closer to infinity, in other words, as our x values keep going to infinity, the range approaches a unique number, and that's what we call the limit. As a function, an infinite sequence may also have a limit. If a sequence has a limit, such as the terms approaching a unique number, then it is convergent. In other words, as we keep adding and adding and adding and adding, and it looks like it's going to a specific number, it's convergent. But if not, if it goes on forever and it looks like it's never going to end, then it's divergent. So here's a definition. Let an be a sequence of real numbers and consider that the limit as n goes to infinity, so there's that infinity part, and then you have the function an. If the limit is a finite number, so it gets somewhere, the sequence converges, and L is the limit of the sequence. If the limit is infinite or non-existent, the sequence diverges. So if we write out what we just did, the limit as n goes to infinity of negative 3n plus 12, that actually equaled negative infinity because it keeps on going down forever. It's never, I'm sorry, I'm obsessing over this infinity symbol. There we go. It's going down forever. In other words, it's never going to stop. So this would be divergent. It doesn't converge somewhere. It doesn't land on a certain value. It just keeps going down. So now we're going to determine if this sequence converges or diverges. So let's just do a couple of examples. Let's just do, the first couple. So let's see. A1. So it'd be 1/2 times 1 minus 3. Of course, you can do this on a calculator. You can do this by hand. So this would be 1/2 to the negative 2, which is the same thing as 2 squared, which equals 4. Okay. A1. This would be 1/2, 1 minus, sorry. I'm so sorry. This is a 2. So this would be 2 minus 3. So this is 1/2 to the negative 1. That's 2 to the first. So that gives us 2. Remember, negative exponents flip the fraction. All right, now we're getting to the easy part. 1/2 to the 3 minus 3, which is 1/2 to the 0. Anything to the 0 is just 1. Okay, so then you have a to the 4th. Let's see, it's 1/2, 4 minus 1. That equals 1/2 to the first power. That's just itself. All right, now we have, let's do a to the 5th for good measure. Okay, this equals 1/2, 5 minus 1. Okay, this would be 1 over 2, oh, sorry. This was a 4 minus 3. And this is 5 minus 3. So it's squared. So that gives us 1 over 2 squared, which gives us 1/4. Okay, so they're getting smaller. Notice it's 4, then 2, then 1, then a half, then a fourth. Well, let's just skip ahead to 8 to the 10th. Let's see what happens. So 1/2, 10 minus 3, that gives us 1/2 to the 7th power, which when calculated gives us 1 over 128. Yeah, that's a really small number. We can guess that as we get closer, that's going to get infinitely small, which means it goes to 0. So then this would be the limit as n goes to infinity, so that means you're going forever, of 1/2 to the n minus 3, that actually eventually goes to 0. So this converges at 0. Okay, if you were to graph it, let's see, what do we get? At 1, we got 4, then we got 2, and then we got, let's see, at 3, we were at 1, and then at 4, we were at a half, and then see how, let me zoom in, it gets smaller and smaller and smaller and smaller and smaller, smaller. Eventually, it gets perfectly flat right at 0, and it doesn't go beyond 0. You can also tell by listing the terms instead of graphing. So yeah, I mean, we graphed it, but then if you list out all the terms, look what happens. 4, 2, 1, a half, a fourth, blah, 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 1/28th. And then eventually it's going to be, like 1 over a billion or something like that. Well, that's really, really small. That's practically 0. Okay? So there you go, ladies and gentlemen. That's converging and diverging. On the next page, all you got to do is just list out the terms and see whether it converges or not. So thank you so much for stopping by. I will see you all next time.